Hello everyone, myself Manikanta. I am presenting the Emertche internship. I am a third year Electronics and Communication Engineering student from Gandhi Institute of Engineering and Technology. During my internship at Emertche, I worked on a project called Real-Time Electric Vehicle Dashboard and ADAS Warning System. In this presentation, I will explain the project, the tools I used, what I learned, and finally demonstrate the project. This project I do under Madam Jayalakshmi and Dhanya. About the internship, during my internship at Emertech, I developed a real-time electric vehicle dashboard and ADAS warning system using the STM32 microcontroller. The system consistently monitors vehicle parameters like speed, battery status, brake status, and obstacle distance. It displays these values on a dashboard and generates warning messages whenever an obstacle is come. Then the warning is detected. I used STM32 Cube ID for programming and fixing lab to simulate the hardware before testing. This internship helped me improve my embedded C programming and STM32 programming. And then move to the next slide. Project requirement. To complete this project, I used several softwares. Tools like STM32CubeID was used for coding embedded C, was the programming language, Fixing Lab to simulate the STM32 board, and TerraTerm. Finally, to visualize our dashboard, we use TerraTerm, monitor UART communications, and VSP, Virtual Serial ports between the simulator and terminal. These are the main basic requirements of our project. And then one by one, part tools I used. And then move to the tools used. STM32 Cube ID. It is used for the writing and compiling debug and embedded C code. And Pixim Lab. It is used to simulate the STM32 hardware and testing the dashboard before physical hardware. And TerraTerm, monitoring UART serial communication. And then move to the next slide. VSP, Virtual Serial Port Emulator. It is creating a virtual serial port for communication between the simulator and TerraTerm. And finally install Python 3 for text in using command prompt. And then go to the next slide. In the internship, day-wise, what I learned, I will tell. The slide shows my daily learning progress during the internship. Initially, I learned the PiximLab environment and LED blinking. First of all, I madam tell about the what what was the importance of the STM32 and how can I use the STM32 for coding, and then ma'am start the programming. First, madam tell about the blink programming, blink LED, and then day two tells about the ADAS code to read speed, brake, and SOC of a vehicle, and then day four ultrasonic sensors implementation, ultrasonic dots and H implemented and complemented. compiling, and then map tell about to compile about three ultrasonic sensors front, back, and left. And day 5 tells about timer 1 code. And day 6 starts about EV controller. From this, we start our main project. In day 7 tells about the VSM, which vehicle state machine and fault manager. In day 8 tells about ADAS.c and ADAS.h files. This tells about collision warning and critical triggering at current distance TTC thresholds. On day 9, we start URT protocol and common cell. And day 10 URT.cell files we implemented using VSP tool. And day 11 we visualize our final project Python installation dashboard. And then go to the next slide. Overall, what I learned the embedded C programming using STM32 and and the next map tells about GPI and ADC timers, UART communication, ultrasonic sensor interfacing simulation using PiximLab, and then we gained some practical knowledge of embedded system and automotive application. How you use these applications in STM32 and implemented in PiximLab, and then about some information about the embedded system. An embedded system is a combination of hardware and software designed to perform a dedicated task in real time. It is basically used in companies also. In this project, the STM32 microcontroller works as the embedded system by collecting sensor data, processing it, and displaying the information and generating safely warnings for our purposes. Finally, this is the view of the STM32 CubeID. It supports embedded C programming language, integrates STM32 CubeID, MX peripherals. Peripherals means external connections and supports configuration of GPIO and ADC timers, UART tools. Peripherals helps in building and debugging real-time embedded system projects. And then go to the next slide. It is a view of the Pixim lab. In PiximLab, we can first move on file, then load binary file, and then we go to the files and select our file and click on OK. It will shows our menu what was happening in our code, and then allow testing embedded C programming language, and then move to our project, and then move to the project, and then move to the project in HTML32 CubeID. First, I will run my project Blink ID, Blink LED. In Blink LED, first open src. In src, we store main.c files. It is the main.c file of our Blink LED. And then we search, right click on the Blink LED and click on build project. It will build our project. Yes, it shows 0 errors and 0 warnings. and then it shows the click on debug. Click on debug. Here it shows where is the binary file, where is the binary file. Yes, this is the blink.binary file. We copy this one here and move to the Pixim lab. Where is Pixim lab? Then search for here Pixim lab. Here we opens the Pixim lab boards. White, so this one as this is preferable. Here you click file, load binary file, then first of all you copy it and here paste it someplace in documents. I paste the binary file, documents, here the blink.binary file, and then double click on it, and as we see the LED is blinking. It is our project of day 1, and then go to the EV dashboard. Next we see this and move to the ADAS. Click on ADAS core SRC. We can see our IRC also. In IRC we have the main file, and we build our project, and here we write main.h for calling the main function, and all the functions like ADAS for calling the ADAS function, fault, and URT.set. Then every 100 milliseconds it shows our collision. When our and here we write flag function also to detect some errors and collision. It will combine all these like ADAS function it will have, fault function it will have. All functions are combined right in EBS because finally we want this in a visualized form. So we can write all the function in a all the functions in EBS. Then click on build project. We can build a project. Okay. Next, after building project, usually we will go to the Pixim lab. Of Pixim, click on Pixim lab file. Then load binary file. Of binary file, here you can forget to copy there. Yes, I will copy the binary file. Where is the binary file? Binary file, binary file. Okay, as we see evidence, then debug and double click on the binary file. Yes, then click on modules, spare parts. We will see our the view of 4 ultrasonic sensors. Then it is a potentiometer. It will show the acceleration pedal, brake pedal, and SOC, and then motor temperature. After that, we arranged some ultrasonic sensors for front, back, and left. Front ultrasonic we connected to PB0 and PB1, and right ultrasonic we connected to PB4 and PB5, and left ultrasonic sensor we connected to PB2 and PB3. And finally, we have some arranged LEDs to show our collision, blind spot for left, blind spot for right, and we arranged the buzzer also. We arranged a buzzer also. But when we have some warning, it will buzzers. First of all, we increase the front view, front ultrasonic sensor. Then it will show the S. It shows no collision, no blind spot, no S. Because we have front, no vehicles on the front, so it not shows anything. And move the left sensor also, and increase some right, and decrease the front. Yes, it shows both collision and blind spot because we have a warning collision before vehicle and front, and we have a vehicle, so it shows the collision S. Then we finally sees the our dashboard, EV dashboard. Yes, it shows our EV dashboard, and yes, shows EV dashboard will shows the speed and speed history and battery like this. And in command prompt, where is command prompt? Where is the command prompt? Yes, I give my path here, so it directly opens the path. Where I fill the path, then it directly opens. Yes, it is the ADAS bird eye view. It is our vehicle. It is our front vehicle. It shows our torque, no torque, acceleration pedal, brake, motor temperature. It is our speed history, battery percentage, how much we charge our vehicle, how much charge we have, and like this. All these things will show in EV dashboard. Bird's eye view. Yes, like this. All things are will show in our EV dashboard. Finally, I will say thank you because I learned a lot of things from the internship, how to use STM32 and how to use Pixim Lab, all these things. In 1 month, I learned a lot of things. I don't expect I learn all these things. I learn quickly all these things in 1 month. So I thankful to Emertxe Private Limited.